Hey there, future tech stars. Welcome to our exciting journey through data management in MLOps. Think of this as learning how to be a master chef in the world of machine learning. Our slide title reads, Data Management in MLOps. And here's our inspiring message. Master the art of handling data like a professional chef managing ingredients. Let's dive into our first question. How do you handle versioning of large datasets? Here's the answer. Use tools like DVC data version control or GitLFS to track dataset changes. Store metadata and pointers, not the actual data. And here's a fun way to think about it. Like a library catalog system, you track which version of each book exists without storing all copies in the catalog. Here's a helpful tip. Always version both data and the code that processes it together. Next question. What is a feature store? The answer. A centralized repository for storing, managing, and serving machine learning features. It ensures consistency between training and serving. Think of it this way. Like a spice rack in a kitchen, all your ingredients, or features, are organized, labeled, and ready to use in any recipe or model. Helpful tip. Popular tools include Feast, Tekton, and AWS Feature Store. Third question. How do you ensure data consistency across training and serving pipelines? Answer. Use the same pre-processing code, feature engineering logic, and data validation schemas in both training and serving environments. Imagine this. Like using the same recipe card for both practice cooking and serving guests. Consistency is key. Quick tip. Share pre-processing code as libraries or containerized services. Final question for this slide. How is data validation performed in production pipelines? The answer. Implement schema validation, statistical checks, and anomaly detection. Tools like TensorFlow data validation help automate this. Picture this, like a quality inspector checking fruits before they reach the market. Catch bad data before it spoils your model. Remember, set up alerts for data drift and schema violations. Welcome to our second adventure. Data lineage and governance. This is where we learn to track our data like detectives following clues. First question. How can you track data lineage in MLOps? Answer. Use tools like Apache Atlas, Data Hub, or built-in features and platforms like Databricks to track data flow from source to model predictions. Think about it like this. Like following a recipe's family tree, knowing where each ingredient came from and how it was prepared. Pro tip. Document transformations at each step for complete traceability. Second question. What are common data governance practices in MLOps? The answer. Implement access controls, data quality standards, retention policies, and compliance tracking. Establish clear ownership and documentation. Here's how to visualize it. Like having kitchen rules, who can access what ingredients, how to store them, and when to throw them out. Important reminder. Regular data audits prevent compliance nightmares. Third question. How do you handle schema evolution in ML pipelines? Answer. Use backward-compatible schema changes, version your schemas, and implement gradual rollouts with fallback mechanisms. Think of it as, like updating a recipe while keeping it compatible with old ingredients, gradual improvements without breaking the dish. Essential tip. Always test schema changes in staging first. Last question. What is the role of metadata in data pipelines? The answer. Metadata provides context about data, its source, structure, quality metrics, and lineage. It enables better data discovery and governance. Imagine this. Like nutrition labels on food, tells you everything important about what's inside. Smart tip. Automate metadata collection to avoid manual errors. Here we explore automation and privacy. The smart systems that work while you sleep. First question. How do you automate the retraining of models with new data? Answer. Set up triggers based on data drift, performance degradation, or scheduled intervals. Use orchestration tools like Airflow or Kubeflow. Picture this, like a smart oven that automatically adjusts cooking time based on the size of the dish. Wise advice. Include human approval steps for critical models. Second question. What are the implications of PGI and data privacy in MLOps? The answer. Implement data anonymization, encryption, access controls, and comply with regulations like GDPR. Use techniques like differential privacy. Think about it like handling someone's secret family recipe. You need their permission and must protect it carefully. Golden rule. Privacy by design. Build it in from the start. Time for our next exciting chapter. CI/CD for machine learning. This is about building robust ML pipelines like constructing a reliable assembly line. First question. What is the difference between CI/CD in software engineering and in MLOps? Answer. MLOps CI/CD includes data validation, model training, evaluation, and deployment stages. It's more complex due to data dependencies and model performance considerations. Here's a great analogy. Like the difference between assembling toys versus baking cakes. Cakes need ingredient quality checks and taste testing. Key insight. ML pipelines are triggered by both code and data changes. Second question. How do you implement unit testing for ML models? The answer. Test individual functions, data preprocessing steps, model inputs and outputs, and edge cases. Use PyTest with ML-specific assertions. Think of it as like testing each ingredient before cooking. Make sure your salt is actually salt and not sugar. Essential tip. Test data shapes, ranges, and model prediction consistency. Third question. What is pipeline orchestration and which tools do you use? Answer. Orchestration manages the execution flow of ML tasks. Popular tools include Apache Airflow, Kubeflow, Prefect, and cloud-native solutions like AWS Step Functions. Visualize this. Like a conductor directing an orchestra, every instrument or task plays at the right time in harmony. Smart advice. Choose tools based on your team's expertise and infrastructure. Fourth question. Describe how you would structure a CI/CD pipeline for ML. The answer includes stages: code testing, data validation, model training, evaluation, staging deployment, performance monitoring, and production deployment with approval gates. Think about it like a quality control assembly line. Each station checks different aspects before the final product. Important reminder. Implement rollback mechanisms for failed deployments. Welcome to ML testing and approval, where we ensure everything works perfectly before going live. First question. What types of tests do you include in an ML pipeline? Answer. Unit tests, integration tests, data validation tests, model performance tests, bias/fairness tests, and end-to-end system tests. Picture this like a multi-stage food safety inspection. Check ingredients, cooking process, taste, and final presentation. Practical tip. Automate as many tests as possible but keep humans in the loop for critical decisions. Second question. How do you handle model approval stages in CI/CD? The answer. Implement approval gates with performance thresholds, human review for critical models, A/B testing, and gradual rollout strategies. Imagine this like a taste test panel. Multiple people try the dish before it goes on the menu. Pro strategy. Use shadow mode to test new models without affecting users. Third question. How do you automate model retraining and deployment? Answer. Use scheduled triggers, performance-based triggers, or data drift detection to automatically retrain models. Implement automated testing and deployment with human approval gates. Think of it as like a smart garden sprinkler system. Automatically waters plants when they need it, but you can override if needed. Starting advice. Start with scheduled retraining, then add smart triggers. Fourth question. Describe how you use GitHub Actions or GitLab CI for MLOps. The answer. Create workflows that trigger on code changes, schedule model training, run tests, and deploy models. Use secrets for API keys and credentials. Visualize this like a personal assistant that knows your routine, automatically handles repetitive tasks when conditions are met. Helpful tip. Use matrix builds to test multiple Python versions and environments. Now, let's explore security and drift detection, protecting our systems like digital guardians. First question. How do you manage secrets and credentials in ML CI/CD pipelines? Answer. Use secret management tools like HashiCorp Vault, AWS Secrets Manager, or built-in CI/CD secrets. Never hardcode credentials in code or logs. Think about it like like keeping your house keys in a secure lockbox, accessible when needed but protected from unauthorized access. Security tip: rotate secrets regularly and use least privilege access. Second question: what is drift detection in CI/CD pipelines? The answer: monitoring for changes in data distribution or model performance that indicate the model needs retraining. Implemented as automated checks in the pipeline. Picture this: like a smoke detector in your kitchen, alerts you when something's not right before it becomes a bigger problem. Balance tip: set appropriate thresholds to avoid false alarms. Welcome to our important chapter on governance, security, and compliance. This is about building trustworthy ML systems that protect users and meet regulations. First question: how do you ensure auditability in ML pipelines? Answer: maintain detailed logs of all operations, version control for code and data, track model lineage, and implement comprehensive monitoring. Think of it like keeping a detailed recipe journal. Record every step, ingredient, and modification so you can recreate or explain any dish. Efficiency tip: structured logging makes auditing much easier. Second question: what is model explainability and why is it important? The answer: the ability to understand and interpret how a model makes decisions. Critical for trust, debugging, compliance, and bias detection. Imagine this: like a math teacher showing their work, you need to explain how you arrived at the answer, not just give the result. Helpful tools. Tools like SHAP and Lime help explain black box models. Third question: how do you ensure fairness and accountability in ML systems? Answer: regular bias testing, diverse training data, fairness metrics monitoring, and diverse development teams. Implement bias detection in your CI/CD pipeline. Picture this: like ensuring a school's grading system treats all students fairly. Regular checks and diverse perspectives prevent unfair treatment. Continuous reminder: fairness is not just a one-time check. Monitor continuously. Fourth question: how do you handle model security and adversarial attacks? The answer: input validation, adversarial training, model monitoring for unusual patterns, and implementing security best practices in deployment. Think about it like having security guards and metal detectors, multiple layers of protection against different types of threats. Proactive tip: red team exercises help identify vulnerabilities. Our final topic: API security and tools, the finishing touches that make everything work together safely. First question: how would you secure an ML API endpoint? Answer: implement authentication using API keys or OAuth, rate limiting, input validation, HTTPS encryption, and monitoring for unusual patterns. Think of it like securing your house, locks on doors for authentication, security cameras for monitoring, and alarm systems for anomaly detection. Security rule: never trust user input. Validate everything. Second question: what tools help with compliance and documentation in MLOps? The answer: tools like weights and biases for experiment tracking, Evidently for model monitoring, and platforms like Vertex AI or SageMaker for integrated compliance features. Imagine this: like having a personal assistant who keeps all your important documents organized and easily accessible for inspections. Integration tip: choose tools that integrate well with your existing tech stack.